Every single time you go online to check your emails, stream a show, anything, you're tapping into a system that's a bit like a global post office. But here's the thing. That system, the very foundation of how our devices talk to each other, is in the middle of this massive, once-in-a-generation upgrade. We're talking about the huge move from IPv4 to IPv6, and trust me, it's a way bigger deal than you might think.
And it's an upgrade we absolutely desperately need. I mean, think about it for a second. What happens when a global network that's designed for explosive growth just runs out of room? It sounds like something out of a sci-fi movie, but it's a very real problem that engineers have been working to solve for years.
So to really get why, you first have to understand what an IP address even is. And it's simple, really. It's a unique identifier for every single device connected to the internet. Just think of it like a street address for your laptop or a personal phone number for your smartwatch. Without it, data just wouldn't know where to go. It'd be lost.
And that simple fact leads us straight to the internet's big address problem. See, we've been relying on a system that was built way back when the internet was just this small experimental network. Nobody, and I mean nobody, could have possibly predicted just how massive and essential it would become.
The original system, the one we call IPv4, had a pool of about 4.3 billion unique addresses. Now, back in the 1970s, that probably seemed like an infinite amount. But today, with our phones, computers, smart TVs, even our refrigerators all needing to get online, well, that number just isn't nearly enough. For all practical purposes, we've run out. So this aging standard, IPv4, it's been the reliable workhorse of the internet for over 40 years. It's what got us here, but the cracks are definitely starting to show. It was an absolutely brilliant piece of engineering for its time, but it just wasn't designed for the hyper-connected world we live in today. And if you look here, you can see the problems are pretty significant. The most critical issue, of course, is that address limit. It's a major roadblock to the growth of the Internet of Things. But beyond that, it can be a real pain to set up, and security was kind of tacked on as an afterthought, not built into its core. The data packets it sends also have these complex headers that can slow things down. And frankly, it's just not built for our modern mobile-first lives. But hey, the future has arrived and its name is IPv6. This is the next generation protocol. It was designed from the ground up specifically to solve all of these problems and to get the internet ready for the next billion and the next billion after that. Remember that 4.3 billion number from before? Get this. IPv6 uses what's called a 128-bit address space. That creates a number of possible addresses so vast, it's almost impossible to comprehend. Seriously, we're talking about enough addresses to assign a unique one to every single atom on the surface of the Earth, and still have enough left over for 100 more Earths. The bottom line is, we will never, ever run out again. This chart really breaks down the core improvements. You see the address length jumping from 32-bit to 128-bit. That's the magic behind that near-infinite address space. Security is now mandatory, right out of the box, using a built-in framework called IPsec. And configuration? What used to be a manual hassle is now pretty much automatic. So the key takeaway here is it's not just bigger, it's fundamentally smarter.
And all these technical upgrades translate into some very real-world benefits for us. That massive address space, it totally future-proofs the internet for the explosion of smart devices. The built-in security, it just creates a safer online environment by default. A simpler data packet structure means routers can process information faster, giving you a snappier experience. And it's built for the mobile world, offering more efficient and stable connections when you're on the go.
Okay, so if IPv6 is so great, you're probably wondering why haven't we all switched over already? Well, it's a great question. You can't just flip a switch on the entire global internet. This is a slow, super careful migration. Think of it like trying to rebuild a city's entire foundation while everyone is still living and working in it. You have to do it piece by piece.
So engineers are using a few main strategies to make this happen without breaking everything. The most common one is called dual stacking, which is where networks just run both IPv4 and IPv6 side by side. Then you've got tunneling, which cleverly wraps up IPv6 data so it can travel across older IPv4-only parts of the internet. And finally, there's translation, which pretty much acts like a universal translator, letting new and old devices talk to each other. So let's bring it all home. Why does any of this matter to you? Well, this switch is what enables that ever-growing world of smart home devices. It gives us a much more secure backbone for everything we do online, from banking to just scrolling through social media. It can lead to faster, more reliable connections, especially for things like streaming and gaming. But most importantly, it ensures the internet has a rock-solid, scalable foundation to keep growing and innovating for decades to come. So the next time you connect to Wi-Fi, just take a second to remember this incredible, invisible upgrade that's happening all around you all the time. The very foundation of our digital world is being rebuilt, and it's going to be stronger and more capable than ever before, which really just leaves us with one final, very exciting question. What are we going to build on it next?